In this lecture, we will learn about continuous probability distributions. Continuous distributions are the bulk of distributions that we will encounter in business settings. They are very pervasive. The key distinction between continuous and discrete distribution is that for continuous distributions, the outcomes are measured, not countable. They're not countable. And probability is found for intervals of x values rather than for individual values. In discrete, we saw that we were able to find probabilities for countable outcomes. Here, we will find probabilities for x values existing in an interval. And because the possibility of x values given the upper and lower limit are infinite, we'll assume that probability of any one particular value of the random experiment x happening is 0. Then the probability that x assumes a value given in the interval is essentially given by the area under the curve fx. Fx is what we will call as the probability density function. So the probability density function will plot the space of probabilities. One of the most common probabilities that we have seen is the bell-shaped curve or the z-curve. The probability of the value of x happening in any interval will be given by the area under the fx or the probability density curve. The first probability distribution of the continuous kind we'll look at is uniform probability distribution. A random variable is described to be uniform, follow uniform distribution whenever the probability is proportional to the width of the interval or the length of the interval within which that value occurs. So the key assumption here is that it deals with events that are equally likely to occur. And the density function for uniform distribution is given simply by 1 over the interval length, b minus a, where b is the upper limit and a is the lower limit, and 0 elsewhere. So a is, as mentioned, the smallest value that x can assume, and b is the largest value x can assume. So given that a random variable follows the uniform probability distribution function, the expected value is given by a plus b over 2, which is the mean, and the variance is given by b minus a squared over 12. So the parameters or all the moments depend on x, a, and b. A is the lower limit of the interval and b is the upper limit of the interval. So let's apply this to a problem. Here we are told that the value of a stock varies from a high of 25 to a low of 16. So A is our lower value 16 and B is 25. So the stock value varies in this interval. Given this, the probability density function fx, which is 1 over b minus a, is given by 1 over 25 minus 16, or 1/9. So that is the probability density function. And for uniform distribution, we can also kind of plot this. Let's say this is our 16, this is our 25, and the height will be the average, which will be, we've calculated 1 over 9. And this is the length of the interval. So this plots the probability density function for a uniform variable varying between 16 to 25. So now the first question asks us to find the probability that the value of the stock is more than 19. So 19 would be somewhere here. We want to find the value which is more than 19, so it's the right of 19. And the length of the interval is equal. So what we could do is we could find the value that is less than 19 in this range, and then we could subtract the value of the stock being more than 19, or we can just look at this interval. So the probability that our x is more than 19 is essentially the width of the interval would be 25 minus 19 times 1 over 9, or 6 over 9, which is 2/3. So probability that the value of the stock is more than 19 is given by 2/3. So let's look at the next question. It says, what is the value of probability of the value of the stock between 19 and 22? So for part 2, we define the value between 19 and 22. We define the value of the stock which is less than 19 is less than x, and this is less than 22. So here we could again work on it with multiple ways. We have found the value of the stock more than 19. 22 would be somewhere here. So we can again find the width of this interval, and this interval's width is 3, and we can multiply it by the density function. So it's simply 22 minus 19 times 1/9, which is 3 over 9, which is 1/3. So 1/3 is the probability that the value of the stock will lie between 19 and 22. Now this third question is interesting. It wants us to find the upper quartile, so the value above which 25% of all the stock values will lie. So the probability will be 0.25. So we can kind of use the same analysis. We're saying that the probability is 0.25. And what is this probability? The probability is given by the width times our probability density function, or fx. So which is essentially width times 1 over 9. So 0.25 equals whatever our width is times 1/9, which implies that our width is 0.25 times 9. And let's see what that is equal to. This equals 2.25. So the width of the interval is 2.25. And then to find the value above which the length of the width will be 2.25, we can take our upper value. Our upper value is 25 minus 2.25, which would be 22.75. So above 22.75, there will be a 25% distribution of the values. So our third quartile is 22.75. And then to draw the graph, we could this is our 25, this is our 16, this is 1/9, and then we have 22.75 here. And the shaded area would be the upper quartile. So let's see how we can calculate some of these values in JMP directly. So to launch JMP, there's a very nice utility in JMP called the distribution calculator. To access that, we will go to Help, then Sample Index. It opens up this dialog box. We'll click on Tools, and then Calculators, and then we will choose the distribution calculator. We can double click and open it. So this distribution calculator is a really powerful interface which will basically help us answer a variety of questions dealing with all the continuous probability distributions, even discrete distributions that we'll be working with. So here we will choose uniform distribution. And our situation was that the lower limit of the stock value was 16 and the upper limit was I'll write 25 here, and then we'll write 16 as the first value. So our values lie between this and the density or expected value was 1/9, which jump automatically kind of points out here. And this will help us find the various answers. So for example, if we wanted to find out the value that will be on the third quartile. So here you can say input the probability and calculate the values. Let's say we want to find the value to the right. So we would have said the right tail probability, and we want the area to be 0.25, so 0.25. This will be our third quartile, and we see that this is 22.75. So we can kind of answer a variety of questions using dealing with uniform probability distribution using the JMP distribution calculator as well. If we wanted to find the probability of the stock values between 19 and 22, we are given the two values. I'll choose this first option, input the values and calculate the probability. We want the value between the interval 19 to 22. Our lower value is 19. We can type in 19 here, and our upper value is 22. And 22. So 0.333 or 1/3 as we had calculated. So again, this is a very useful utility in JMP. It will help us calculate either given the values, the probability, or given the probability, the values corresponding to that probability area.